All right, here we have number 12 from the SOA's released questions for exam P. And if you've been practicing these triple Venn diagram problems, it should be pretty straightforward, but there's a well-laid trap here in the middle that will direct you towards answer choice D. So let's have a look at this one. Here is the, we'll get to this in just a moment. The Venn diagram I've created already. I think determining where these values go is very straightforward. We're told straight away that having only one of the characteristics of the disease, either A or B or C, but not the others, is always going to be 1% or 10%, 0.1. So I've labeled accordingly. And just the same, having any two but not the third is always 0.12. So I've labeled that. And then we're given a conditional probability statement here that we're going to use to find this intersection, the triple intersection point right here. So this is the very mathematically sort of proof-oriented probability language way to make this statement. What that final sentence is really saying, the probability that a woman has all three risk factors, given that she has A and B, is 1/3. Given that she has both A and B, means we're limiting ourselves to this football-shaped intersection right here. And given that we're talking about just that football-shaped section right there, this portion in here, the intersection, is exactly 1/3 of the total. So if you have strong number sense, you might very quickly see what that value is going to be in the center. But let's go ahead and write it out algebraically. X, we'll call this intersection that I've shaded here, we'll call that X. And then the total of the intersection of A and B is X plus 0.12. So if you just put in 0.12 for your denominator and charged onto the end, there's a good chance you did everything correct and still got the wrong answer because your denominator was wrong. This is the trap. This is how we avoid the trap that takes us to answer choice D. We'd be sure we've got our total of the intersection of A and B, which is 0.12 plus some unknown bit that we don't know here in the center. An unknown bit we don't know. Okay, so this is equal to 1/3, and then from there it's algebra. 3x equals x plus 0.12, subtract x from both sides, divide both sides by 2, and you get that the intersection point is 0.06, or the triple intersection is 0.06. And then in hindsight, that kind of makes sense, right? 6 is 1/3 of 18. The total of the intersection of A and B, or B and C, or A and C for that matter, is going to be 18. Okay, so to get to the answer, the question that we're actually asked, calculate the probability that a woman has none of the three risk factors given that she does not have a risk factor A. So I've written that statement here. The probability of not A, not B, not C intersect is everything outside the circles. So we do a little bit of calculator work. 0.1, 0.1, 0.1 is 30. 0.12, 0.12, 0.12 is 36. So that's 66 plus the triple intersection is 0.72. 1 minus 0.72 gives us a numerator here of 0.28. And then the probability of not A, that's everything outside circle A, 0.1, 0.1, 0.12, 0.28, that's 0.4, 0.5, 0.6. So 0.28 divided by 0.6 is 0.467, or 46 repeating. Answer choice C. So great question here. Watch your denominator when you are solving.